Now we move to the next slide. Graphical representation of motion. The first is displacement against time graph. In this graph, you can get the velocity from the gradient of the graph. Here, our displacement in y-axis and time in x-axis. The straight line slope indicates the velocity is constant. The steepest straight line slope means the velocity is larger than this one, meaning the velocity is increasing. The horizontal line here indicates the zero velocity. The object is at stationary or it stops. Next, this slope indicates uniform velocity returning to the starting point. Next, when you come across with the curved line, you can see over here the slope of the curve is increasing. So, what means by that? The velocity is increasing. The next curve, you can see over here, the gradient is decreasing. So, the velocity is decreasing. Next, when you come across with this curve, you can check the slope over here. It is getting less steep or gentle slope. That means the V is decreasing and it is returning to the start. While for this curve, you can see over here, the gradient is increasing, which means the V is increasing and it going to return to the start point. Okay, now we come to the velocity against time graph. Velocity is at y-axis, time is at your x-axis. Here we can see that this is considered as forward direction because we have positive value of velocity, and this one can be considered as opposite direction because it has negative value of velocity. This is the point where it turned back, meaning, for example, the car moved to the right and then it moved to the left. Okay, from the velocity against time graph, we can get the acceleration from the gradient. Here we can see that the slope is increasing. So it means that the object is speeding up, where the first line indicates the smaller value of the slope, smaller gradient, while this one is more steeper. That means it accelerates quickly. What means by the horizontal line over here? It indicates the velocity is constant or uniform velocity. When the velocity is constant, the object is not accelerating at all. The acceleration is zero. Next, this line tells you it going slow down and it has rapid deceleration. This horizontal line lies in x-axis, so that it indicates the velocity is zero. That means the object is at rest. A equals to 0, V equals to 0. Next, it is changing direction. So this line indicates the object is accelerating in opposite direction. These horizontal lines indicate the velocity is uniform and it moves in opposite direction. Last, the object is slowing down and the acceleration is decreasing and it moves in opposite direction. What can we conclude is, when we have the positive slope, it implies the positive acceleration. When the slope is negative, it implies the negative acceleration. The horizontal line considered as zero slope implies A equals to 0. And as you know, steeper slope means greater acceleration. Another information can we get from the graph is distance or displacement. We can get from the area under the graph. We can calculate the area under the graph and calculate for the distance traveled and also the displacement. For example, over here, the distance traveled is 50 plus 8 because it is scalar quantity. While for the displacement, it can be calculated as 50 minus 8 because it changed direction over here. So the displacement is 42 meters while distance traveled is 58 meters. Next is acceleration time graph. From the acceleration time graph, we can get the change of velocity from the area under the graph. Here it is. As we can see over here, our acceleration at y-axis, time is your x-axis. This indicates the positive acceleration as it is shown over here. How about this one? This is considered as zero acceleration because it lies on the x-axis. And this one is considered as negative acceleration. And it goes back positive acceleration, and last one, zero acceleration. Let's do one example over here. The velocity time graph of a car which starts from rest and travels along a highway is shown in figure below. So the velocity is your y-axis, time is your x-axis. First, determine the displacement of the car within 10 seconds. How? We are going to calculate the displacement. Since this is the velocity time graph, you can get the displacement of the car from the area under the graph. So, you calculate for the area above the x-axis, area below the x-axis, and since the question asks you the displacement, so don't forget to put the negative over here to indicate it is turning back. So, the displacement is 14 meters. Next, determine the instantaneous velocity at time 8 seconds. Determine the instantaneous acceleration at time 8 seconds. Here it is. What is the instantaneous velocity at this particular time? It is obviously 0 meter per second. And now, how to calculate the instantaneous acceleration? Acceleration is gradient of the VT graph. So, you can get the gradient of the graph over here to get the instantaneous acceleration. So, by choosing V2 0, V1 4, T2 8, T1 6, you substitute all the values and get the acceleration is negative 2 meter per second. So, the car is decelerating. Next, explain qualitatively the motion of the car. So by starting from 0 second to 6 second, the car moves forwards with increasing velocity. As you can see over here, there is the slope. Next, from 6 seconds to 8 seconds, the velocity decreases with time and you can get the negative slope over here, which indicates the deceleration. Next, at 8 seconds, the car turns back, so it changed direction. From 8 to 9 seconds, the car accelerates in opposite direction. And lastly, from 9 to 10 seconds, the car decelerates and finally stops.